Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at unique pointers in C++11. These are a kind of smart pointer which behaves like a normal pointer, except they handle the deallocation of memory for you. So memory leaks are a common problem in C++ programs because you don't get enough deletes being called, or the right type of delete, for the objects you've allocated with new. And smart pointers are something that can help you just avoid those bugs by automatically deallocating memory. So I've created a test class here with a constructor so we can see when it runs, and a destructor. And here's just one method. I'm going to use that in a minute. Let's just take a look at an example using a simple int type for a start. So I'm going to type here unique underscore PTR, and this is a template type. So in the template brackets, I need to say what type of thing this is going to point at. Let's say an int. So we don't need int pointer in here, we just need int. It knows it's a pointer already. We don't need int star. We just need the type that it's going to point at. Let's call this p test. And now, because I want this to manage the memory that I allocate with new itself, we can't just say equals new int if we want to do that. We have to do the memory allocation within the constructor brackets here. So we're passing this information via the constructor of this in some kind of a way. So now, by the way, one really important thing that I must mention at this point is you can see that this program builds and it's fine. But you actually, to use smart pointers, you have to include the memory header. So we have to say include memory. And this applies to any kind of smart pointer, including the shared pointers that we'll see in the next tutorial. And you have to have using namespace standard. So the reason that my program just compiled without this was only that if you include pretty much any header, it's probably going to use memory somewhere down the line. So IOStream is already including this header somewhere, and that's why we don't actually need it in this program. But if you don't have include IOStream or some other header that uses this, then you will have to type include memory and using namespace standard as well in order to get this to compile. So that's really important. Otherwise it's quite confusing, because you can see programs that don't appear to include this, and then you find you try to do something similar and it doesn't work because you haven't included a header that happened to include memory. This could be called memory.h or something on your system. Usually it's memory, but maybe memory.h. And I assume it's always going to be memory, otherwise you'd have to just Google for unique pointer and find out for your particular compiler what header to include. Okay, so this gives us a basic pointer to an int, and we could use it just like any normal pointer. So we could dereference it and say thing pointed to by ptest equals 7, let's say, and we could do a cout on it, and it will behave just like a completely normal pointer. The difference is that it's going to deallocate the memory we allocated automatically for us. So in order that we can actually see that happening, I created this test class which will show us when memory is about to be deallocated, because the constructor will be called automatically just before that. So let's change this to make it point at an instance of my test class and say new test in here. This is no longer applicable. Neither is this. But what I can do is I can call the only method that I've given it, which is greet. Let's say ptest arrow and greet. So now that will work just like a normal pointer. But we can see that here at this point we're allocating memory and the constructor is then being called. Then we call greet, which outputs hello. Then we get finished being output in the program. And finally what happens is this local variable goes out of scope when we hit this closing bracket. And at that point the destructor is called and the memory that we allocated is automatically cleaned up by the unique pointer. So the unique pointers, or smart pointers in general, clean up memory when the variable they're associated with goes out of scope, which is just a really clever idea, and most of the time works really well. And just to see that it really is the scope that's causing this to happen, if we put extra curly brackets here, so here and here, format that, we can use curly brackets in C++ just by themselves if for some reason we want to reduce the scope of something, perhaps to ensure that memory is freed quicker than it otherwise would have been. So these are going to mean that this local variable is now scoped to these brackets. So if we run this now, we see that the memory cleanup and the call of the destructor first is going to happen before we output finish, because this variable goes out of scope here now. It's scoped to whichever the first pair of brackets that enclose it are. So prior to C++11, we had auto pointer, which is pretty similar, and here we can just change that to auto pointer and it works. So you're going to see auto pointer if you look at any C++ code that was written before C++11, probably. Well, not all C++ code is necessarily going to use smart pointers, of course, but often it does. Auto pointer is now deprecated, so if you're using C++11 or later, you should use unique pointer instead. Apparently there are some problems associated with it. And one thing is you can't use auto pointer on arrays, but we can use unique pointer on arrays. So if I change the type here in the template brackets to an array, and then when I allocate the memory, I can allocate, let's say, 2 of them, or however many I need. Now I have to change this because this is no longer going to work. I can make it just, let's say, we can access the second object in the array of 2. Now what happens is if I run this, again, just the same as before, we don't need these brackets, and they're just reducing the scope. In fact, let's get rid of them. Format that and run it. But you can see that we're now allocating 2 objects. We're calling hello, then we get finish coming out, and then this variable goes out of scope, and we get both objects are cleaned up. So the entire array, however long it is going to be cleaned up, which is really great. One thing that I want to add here, just because it could sort of catch you out, although you could work it out from basic principles. Supposing you have a class, I'll just call it temp, and supposing you want a private member variable, which is a unique pointer. So we could use this one, for example. Let's copy that, paste it in here, and just for the moment, I'm going to comment this out. In fact, I'll leave it commented out in the code which you can download attached with this video somewhere. So this isn't going to work because we're trying to call basically in effect the constructor of this variable directly here, which we're not allowed to do. What we have to do is we have to create a constructor for our temp class. So I need round brackets there, and let's create that. And I have to use the initialization list to do this. So we can't say in here ptest equals new test2, because then we wouldn't be getting unique pointer to handle the memory itself. We have to supply the memory we allocate. We have to do it in these kind of constructor brackets or whatever they are. I'm not completely sure what type of thing unique pointer is. It's not relevant really. You can look it up if you want, but the point is you've got to supply this in these brackets, which definitely look like constructor brackets, whatever they actually are. So let's copy this, and I'm going to use the constructor initialization list. So paste it in there, and then I need to delete this here, so we're only declaring the variable here, and here we can actually initialize it in the constructor initialization list. So if I build that and run it now, we shouldn't see any output. Let's just run it. But if I create a temp instance now and we run this, then we do see that we've got our two objects being allocated, and they're also being destroyed as well. So now we no longer need to have a destructor that does that memory allocation in this class. It happens automatically when this local variable goes out of scope down here, because when that happens, its instance variables go out of scope as well. They get destroyed basically, and at that point the unique pointer will clean up the memory before the destruction happens. Okay, so that's it for this tutorial. To practice this, certainly worth going through the steps that I just showed you. Try allocating one object with unique pointer, try an array with unique pointer. Check that you can allocate single objects with auto pointer as well, because it's worth just, if you haven't seen it before, it's worth getting auto pointer in your mind, because you'll probably see it in C++ code in the future if you do much coding. So, but remember, you can't use auto pointer to work with arrays, and auto pointer is deprecated, so we should use unique pointer in C++ 11 and onwards. And probably a good idea to try this as well. Try using an instance variable of a unique pointer in your class. And finally, if you've got any C++ code that uses pointers, you might want to try converting it to using unique pointer and getting rid of the deletes in there. For example, the project that I showed you in the Free Beginners C++ tutorial, if you've seen that uses pointers and just deletes them, but you could use unique pointers there to do the same thing. So that's a bit of an extended challenge if you want it. Otherwise, at least it's a good thing to try typing this out and getting it all working, verifying all this on your compiler. Okay, so that's it for this tutorial. In the next tutorial, we'll look at shared pointer, which just adds a slight twist on this. It's useful in some situations. And until next time, happy coding.